Welcome to week 7. No, I am not Sasha. You'll remember Sasha. Well, she went to a conference in Toronto, the premier computer science education conference in the world in Toronto. Invited talk at New York University, apparently went well. And now she's in LA, so you get her back next week. But until then, you've got me as your lecturer. All right, what's happening in 1511? Assignment 1. Hopefully there's no one going, oh my God, there's an assignment 1, because it's due in 9 hours. All right, because you're here, I assume you're one of the sensible people that started this assignment a week or 2 ago. If you're not, if you're listening to this and you didn't start this assignment, you started this assignment, Saturday night or Sunday, take this as a lesson. Computing assignments can't be done the night before. We're doing something wrong if we're giving you assignments. Generally, they can be done the night before. Or you're a super genius. One or the other. What else is happening? Assignment 2. Assignment 2 is coming out later this week, and it will be due. When will it be due? We're thinking week 10. We're not exactly sure. Sasha will tell you next week. So you might plot that on your little planner above your study desk, working on assignment 2. All right, hopefully assignment 1 was educational, you learned stuff. Okay, I'm not going to say it was easy, that would be wrong, but hopefully you didn't hate it. If you hate everything you're doing in your degree, the end of first year is the time to think about, well, should I change to another degree? Should I, plumbers are earning good money, should I do that? Would I be happy? No, I'm serious. Would you be happier working as a plumber for yourself? Would you be happier becoming an architect? End of first year, but don't fail anything, please, in the interim. But the message should be, you should be liking some of the stuff you're doing. It doesn't have to be easy, but you should be liking it. All right. Let me just, why is that room so dull? Lighting. Maybe 50% is better. There we go. All right. Today's topic, well, Sasha's given me slides. All right. So this is not last week. Last week was Flex Week. Week 5, what we did in week 5. And that's Sasha saying, did you miss me because Andrew's a horrible person? But that's, to be fair, most lecturers aren't as nice as Sasha. All right, which is why we've given her to you for your first computing course. It's not an accident. Sorry, the slides aren't available. Access the slides on the website. So one of our team of tutors over there will work on making the slides available on the website. Sorry about that. The slides will be shortly available. All right, so today we've got to get through, some hard topics. Sasha has really given me the hard topics, hasn't she? Pointers and memory allocation. And we'll get to my favorite function, which you won't really need to know, but I'm still going to tell you about it because it's fun, realloc, hopefully. There's a lot to cover, so let's move on a bit. Live lecture code can hopefully be found there. Hopefully everything I type on my laptop is being transferred by rsync to the class website where you can access it by HTTP. And if you don't know what either of those things are, come and do COMP1511 with me. Sorry? All right. All right, assignments we've discussed. Live stream on Thursday for the assignment. Is that right? Yes. Okay. All right, let's talk content then. Pointers. What's a pointer? Yeah, it's a bit more abstract than the types we've seen so far. What are the types? Types is a huge thing in computing, which you get your first taste of in this course. A crucial thing, there's a whole field of maths built around types that exists for computing only. Well, mathematicians would probably have it anyway, but it'd be useless. So types, you've seen int and double are two types of things you've seen. I guess void is I'd call it a degenerate type. It's an empty type. Int and double sort of makes sense. Integers you've been dealing with since you were 5, 4, 5, something like that. Doubles, representations of fractional numbers you've been dealing with since, for a long time. Pointers, not so much. What's a pointer? A pointer is a redirection. A reference, I guess, is the most classical term for it. A pointer isn't something, but it can lead you to an object. What sort of object? Oh, I was wrong. You've seen two more sorts of types in 1511. You've seen what I'd call compound types, which are constructed types built of other types. The two constructive types are arrays, and for the first Mars bar of the day, what's the second constructive type or compound type you've seen in 1511? Oh, who was? Well, I saw your hand first, so you get it. The virtue of sitting front and center with a lecturer with poor peripheral vision. All right, structs and arrays. So a pointer can point to an int variable, can point to a double variable, can point to a struct, can point to an array, and we'll see all of those. But when we so there's a crucial piece of syntax, and it's tiny there. It's that little asterisk. That little asterisk changes everything. If I say int Mary, that means Mary is the name of a variable that can hold a single int. Put an asterisk there. It's not a variable that can hold an int at all. It's a variable that can hold a reference to a variable that can hold an int. It can lead me to a variable that can hold an int. So when I just say int star pointer there, I get a variable that can hold a reference, but only to a variable that contains an int. You can't have, well, it's not quite true. In this course, we'll only see, even that's not quite true. We like to type our pointers, and we'll generally be using typed pointers here where we say what sort of variable it leads to. Yeah, if you Google about this, there's endless confusing stuff you can get into with this. Be very careful about this, researching it on the internet. Looking up stuff, alternate sources of knowledge, reading lecture slides from other universities, great. But just be aware there are complex issues that go way beyond what we need to know to get through 151 with pointers. 1521 will take you through some of those issues, but not all of them. But wait. All right. Yeah, I don't think I want to talk about that. I did want to recap this one. So asterisks. I use it when I'm declaring a variable to say this is a pointer. It gets another go. Asterisks are a really popular operator, I would say, in C. It gets used for 3 different things at least, maybe more. So what it means depends on its context, which does make life hard for a beginning programmer like all of you. So let me see if this works. There's the asterisk in the declaration. Down here, I can use an asterisk in my code with a pointer to say, I want to talk about the object that this pointer points to. That's called the word you'll often see for this is dereferencing. It says, take this pointer, follow it. I want to deal with what that pointer points at. It has an inverse operation. The inverse operation is ampersand. Oh, I'm drawing on the wrong screen. There we go. The inverse operation is ampersand. That says, give me a pointer to something. So you could compose a string of asterisk, ampersand, asterisk, ampersand, asterisk, ampersand, and do nothing, because each one is the opposite of the other. It would be a bit silly, but you could do that. So beware, asterisks and ampersand both have other meanings in C codes. What's the other meaning of asterisks that I haven't mentioned yet? Yep, multiply for the second Mars bar of the day. Perhaps a bit too easy to deserve a Mars bar, but I'm in a generous mood. All right. Come and 1521, we'll get to another meaning of ampersand if you come there. All right. I think I'm almost ready to. Whoops. Yeah, that's nice, but I want to show you some code. All right, enough slides. Let's go to a bit of code and try and look at the code. I can get there, code. On the screen, code. All right, I apologize, I don't use VS Code, but it's actually not a bad thing for you to see other editors. You'll have to use other editors in various contexts, even if you're love VS Code. There are places you won't be able to use it. So, oh, let me draw on the right screen. Null. Null's a weird thing. Why do we have null? Sometimes we want to give a pointer variable a value, but we don't want it to point at anything. So we want to have a special value to say, yeah, this pointer value doesn't point at anything. So null is that value. It's a special distinguished value that says pointer not pointing at anything. So if you've got an inquiring mind, you'll be saying, what happens if I do an asterisk of null? And they say, dereference null. Give me what a pointer containing null is. That's an error. With DCC, you'll get an immediate stop of the program. In most C implementations, you'll get an immediate error. There are circumstances where your program might do bizarre things. All right. So I've declared two int variables, declared two pointer variables, not made them point at anything. Here, let me say, this is a means to an end. You don't often, well, I guess you sometimes, pointers and int variables are not so exciting. We're going to do really powerful, start on really powerful and exciting stuff with pointers on Thursday, but this is sort of walking before we can run. Thursday, we start to run. Today, we'll try walking. So that says, make this pointer point at this variable. What that really does is, makes this pointer point there, makes this pointer point there. So that's what these assignments here do. That's you getting the value of the pointers. All right, let's scroll down. Not too far. Oh, I like this code. This is actually Sasha wrote this code, but I like that one. That's a thing of beauty. That's showing you, because this code will, I'll show you this code compile and work, but that's demonstrating anywhere I can use an int variable, I can use an int pointer variable with an asterisk. So anywhere an int variable can be used, I can get an int pointer variable and say, dereference it, and I've got the same as an int variable. And Sasha's done it and said, look, I'll put it on the left-hand side and the right-hand side, both sides. Let's run this and show you that it works. All right. This is a program you should understand everything of, with one little exception, which I should explain, I guess. When I work out how to, there we go. I flick that to full screen. Oh. And run it again so it doesn't wrap. Weird number here, weird number there. What are those numbers? You don't need to know, actually. All right, I guess you do need to know. We want to know so much. We want to know things that... So exactly what this is isn't particularly important for 1511. It becomes incredibly important once you get to 1521. But that's a RAM address, because that's how pointers are implemented here. It's actually the RAM address of where the variable is pointing. And that's how most C implementations work. All right, tell me something else about that. It's a RAM address. What does the 0x mean? I don't think you've... It means hexadecimal. All right, I'm going to test my throwing arm so I can see if I can hit the person who said hexadecimal. Hold still, hold still. Oh, look at that. All right, hexadecimal means base 16. Again, that's a side note, but it's best to have these things. You know, put up a post-it note in your study room, say, learn about hexadecimal after the exam. It is useful to us because we can see if two pointers are the same. If we print out two pointers, and that's in your future, a problem for future you, are these two pointers pointing at the same thing? If they point at the same thing, the weird hexadecimal number will be the same. If the pointers are null, here's a secret tip for you, it'll be 0. I could actually demonstrate that. I like demonstrating stuff because then you can see it for yourself. So let me grab, yeah, so this is the sort of stuff you should be doing to understand this. Get example code like this. There'll be a nicer version of this available. And play with it. So you're wondering what happens if pointer 2 is null. Well, actually, yeah, we'll make it null and dereference it first, which will fail. But we'll see that. Let's see that failing. Dereferencing a null pointer. That should be good. You'd think I'd be able to spell by now. Actually, I sent a really important email on Friday, and I misspelt the subject badly. And then since then, there have been about 15 replies from heads of school and things like that, all with my misspelling. It's very embarrassing. Oh, okay. Yeah, I mangled that. So that message there is saying, Andrew, this is one of the things I tried to get. Maybe you never know when you're a lecturer. Are you saying the obvious and everyone, all of the class is saying, I know that, or is this enlightening some people? That says warning there, and you might think, okay, I can keep going. No, that means stop, stop, danger. That's saying printf, the arguments you've given to printf don't match the % fields you've put in the format. And it's not going to work. It's just not going to work. That's just wrong. It's really a typing thing, but in a sort of weird special case. So I wanted to print it out there. All right, now it matches. Now to compile. Now I'll dereference a null pointer. And DCC stops me with a runtime error. It's saying you've said asterisk of x, where x is a pointer variable, but x contains null. You can't do that, Andrew. Stop. So just to be clear, there's there's number 2 pointer. Here I said asterisk number 2 pointer. That failed. Let's get rid of the asterisks and keep going. And delete the %t. So we'll just print out the address of the null pointer. I just wanted to show you, it'll print out as zeros. If I've got it right. Hey. All right, printf is smarter than Andrew. All right, because it's a %p format, printf prints it out as brackets, nil brackets. Well, I guess that's good. All right. My message was, if you want to get through this course, if you want to learn, you've got to do things like this. We're not mathematicians. We can test things so easily. Actually, mathematicians have got programs these days to let you test lots of things. But still, get these things, change them, test your ideas. If you think, oh, I can do this with a null pointer or I can't, test it. We've also given you a DCC that tries to check everything. So if you do something that's not allowed, DCC is meant to pick it up. I have another program here. All right. Here's a little bit of the meaning of life explained for you. Well, perhaps not quite the meaning of life. So a few weeks ago, Sasha probably said, when you want to use scanf to input a number, put an ampersand in front of the variable. I can't really explain why, but put an ampersand in front of the variable. Now you know why. Because scanf wants a pointer to the variable. So scanf doesn't want the variable, it wants a pointer. Because it wants to change the variable. We'll look at that. All right, so before this lecture, I asked ChatGPT to give me a C program that did this. I think it's not quite right, though, like a lot of things coming out of ChatGPT. So it's meant to read numbers and then shuffle. It's meant to read 3 numbers, print them. Swap the first and the second, print them. Swap the second and the third, print them. Swap the third and the first, print them. All right, you can, I'll give you a clue. This code is pretty good. Oh, no, it's not going to compile because there's a stray ampersand there. It just shows you should compile code before lectures, Andrew. Let me try compiling it. Oh, it's also a little worrying, but anyway. Oh, come on. Sorry. Yes, I sort of half made changes I want to make to this code. I've got the prototype wrong. All right. There we go. Let me run this code and we'll see it doesn't work, as you might have guessed. I'll enter 3, 4, and 5. Oh, and the prompt's in a bad place. Contemplate that shuffle routine. Yes, I know it's Monday. It's been you had a big election night party, you're still recovering. Actually, no, you didn't. You were working on the assignment. That was me that had the big election night party. Well, to be fair, that was mainly me shouting at the TV by myself and my partner saying, Andrew. But anyway, look at the code. Look at the code. There are a couple of things wrong with the code. You're going to tell me one of the things wrong with the code?
The shuffle method should take a pointer to the integers, and also you need like a temporary one to store one of them without overwriting.
All right, you're overloading me here. You're completely right. I'm only going to give you one Mars bar, not two. There are two things wrong with ChatGPT's effort here. This is the sort of mistake you make if you're a mathematician coding. You don't think about, mathematicians think about equations and solving simultaneous linear equations, but those are assignment statements. They take place in sequence. My friend here, his second point is, I haven't thought through my sequence. What is the result of those assignment statements? No. So why is he wrong when he says nothing? Yes, completely wrong. What is the result of the assignment statements? Yes. All right. So my friend in green said I needed a temporary variable, and he is right. So if I want to swap two values, the coding trick is something like this. All right, so much better. Now, you did have two suggestions, but we're going to go with your second one first and show that it's insufficient. Wait. Just wait. Still waiting. Still waiting. All right, that didn't work. But this is something we can be aware of. The need for a temporary variable, completely right. It's just it's not sufficient. All right. Now, I said I wanted you to be like you guys, like these three guys here. Sorry, guys. These three people. Let me not misgender the tutors. It's Monday. All right, these three brilliant people here who can look at this code and read it and tell it it's wrong without seeing that function. So how can Tom look at this code and tell it's wrong? I'm not asking you, Tom, by the way. What type of oh, it's just off the screen. What type of, when you see code, you always should be saying type. What type is num1? And num2 is in it as well. If I call a function like that, can it change num1 and num2? No. And this is a big thing in reading code. It's a huge thing in reading code because it lets us reason. And I've said you've got to start reasoning more. I know it's hard because it only seems like a day ago you learned this is how a for loop goes around. But you've got to start making logical, you've got to treat it as a logic puzzle and be able to reason forwards and backwards about code if you want to succeed in writing lots of code. So that can just never work. So my friend in green can say, look at that and say, no, that can't work. Num1 and 2 can't be changed. This num1 and num2 and num3 will be unchanged. You just can't change an int variable like that. So his suggestion was, all right, I'll give you the Mars bar now. I should give you the Mars bar now. His suggestion was to pass pointers. So he wants to do that. How does that help? Sorry, this is going to be a bit tedious as I update my code. How does that help? I can fetch the int variable at pointer 2 points to and put that in temp. That's great. But watch this. Watch this. This is just great. This is something we haven't been able to do until now. That says get whatever pointer 2 points to. That's not so exciting. But then put it in the variable at pointer 1 points to. I can change a variable. What variable am I changing? Is that variable here? Oh, I haven't finished. Wait, let me finish and we'll see if... I'll give you a Mars bar if you're right and I'm wrong. I think I'm right. Oh, no, wait. You are all right. Sorry. There's your Mars bar. Nothing worse than a student being right. No, actually, that's what we're trying for, isn't it? We want students to be right. What am I saying? It's my job to make you right. Ah. Well, really, I guess Sasha can take credit for it. But still. All right. By the way, this is not an uncommon thing you'd have to do. You say you make it an int variable, and you think, oh no, this function's actually got to change that. I've got to pass a pointer instead. Some students then have sort of a genius brain thing. I'll just pass pointers for everything. It's best avoided. If you don't need to pass a pointer, you can just pass a value. Do that. Only use pass pointers when you really need it. It just makes your code too complicated. Yeah, you're.
So you know the temp variable, doesn't that also have to be type pointer?
Sorry, doesn't the
temp variable, wouldn't that also have to be a pointer type?
Oh, it's a good question. That's a question that's actually worth a Mars bar, even though my code is right, but it's actually an excellent question. I believe, I'm asserting I've got the code right. I have been wrong before about that, but 3, 4, 5. Look at that. That's what the code is meant to do. All right, so my friend here was saying, Andrew, the temp variable, you've made that an int. So it has to hold a value. What does it have to hold? It has to hold an integer. So the correct type for it is int. I could set up a pointer variable pointing to temp and use it like that, so I could do it. But, well, let me ask you two questions. Drawing on the correct screen. What pointer 2, what type is it? I'd say int star because I've been C programming a long time. Pointer to int is perhaps a more English way of describing it. Asterisk pointer 2. Pointer 2 to reference, what type is it? It's an int. What type is temp? It's an int. But it's a superb question. That should have been, well, okay, some of you were asking that and answering it in your heads, but you should have been asking that in your heads one way or another. All right. Oh, I think Sasha had a slide she wanted me to do too, and I've skipped it. Well, we can do it quickly. Oh, all right. So this is a let me know in the chat question. All right, checking the chat. There are four assignment statements there. Assignment statement 1, good or bad? Thumbs up or thumbs down for assignment 1? Oh, I'm seeing a lot of thumbs down here. What's the chat saying about it? Oh, come on, chat. All right, it is wrong. Look at the types there. Number, right-hand side is an int. Left-hand side is a pointer. You can't assign a pointer to an int. What about that? Does that make sense? Yes or no? We're getting a lot of no's and one brave yes. Sadly, the brave yes is brave but wrong. What type is asterisk number? Number is an int variable, so I'd say asterisk number is an int star, but if you want to talk more English-like, you'd say it's a pointer to an int. If number is an int, putting an ampersand in, sorry, ampersand. Let me point at the right thing. That is a pointer to an int. What's on the left-hand side? Num pointer is a pointer to an int, but once you put that asterisk there, you're talking about an int. It doesn't match. Do the types on the left-hand side and right-hand side of an assignment statement have to match? We've got one person a bit doubtful. There is they generally have to match, but there's an exception. What's the exception? Char and int, it's an interesting one. It's not what I'm thinking of, though. Int and double is the one I'm thinking of. Have you had a Mars bar yet? No Mars bar for you yet? All right. So for the most part, they have to match. C has given some special cases where it thinks it's safe and it knows what to do. Well, the designer of C, yep.
What about end of file? End of file or control D? Are those the same type or is there another exception?
So EOF, it's actually an int. And getChar gives you an int. EOF is a special int value returned by getChar. Yeah, it's an interesting question about types, but it's at a different level in the system.
Right, I think it's lower level.
Yeah, yeah. All right. In my revision, yes or no? Is that okay? The person munching on his Mars bar already is saying yes, fueled by sugar. Yes, that's all good as far as I'm concerned. Number is an int variable. Ampersand gives me a pointer to int. Number pointer on the left, it's assigned to, takes a pointer of an int. That's great. And the last one, is that okay?
Yeah, it doesn't achieve anything though. Assigns number to number, right?
That's actually a tricky one. Are the types okay there? Types are okay. What worries me about that assignment statement? I can see 3 worried tutors there. Actually, I can't. Two of them are they're looking at the chat, of course. Sorry. I was about to say they're on Facebook. You know. What worries me?
Bad start. You have to have a space on both sides of the equals.
So that actually does worry me, because that sort of thing does worry me a lot. No, that's not what I'm thinking of. But yes, the formatting is weird, yes?
The variables are uninitialized.
Oh, you've made my day. Sasha has done such a great job with you guys. Sorry, Sasha and the entire tutoring team. How can I be so mean? Initialized. I hope that got to you. Whenever we use a variable, we always worry, what value have I previously given it? Whenever I use a variable, you should be waking up at 5 a.m. thinking, oh my God, did I initialize that variable in my assignment I submitted last night? So from the middle of the theatre, they're saying, has num pointer, well, how do you initialize a pointer? 2 ways you can give it. You can assign null to it, but if it's been assigned null, that's still bad. Has num pointer previously been made to point to something? That would be my question there. So this is what you should be asking. These sort of questions are going to be in your mind as you read code from now on. For the upcoming weeks, you'll be dealing with pointers. Assignment 2 is dealing with pointers, I'm pretty sure. Yeah. So this is your life for the next couple of weeks. Well, apart from maths and whatever other courses you're taking. All right, I've done that. We've done the swap. Oh, all right. All right, Sasha's done lovely slides, which you can read at your own pace, but I've got another example. All right. I want to try structs and pointers, making a pointer point at a whole struct. So Sasha's got an ice cream struct. Apparently Sasha only ever eats ice creams that have a max of 15 characters. Well, actually there can only be 14 characters in the name, can't there? Because there has to be a terminating null. I don't know about that. Some of those complicated flavors would go well over 14 characters, I think, but all right. That should worry you, by the way. Programmers always, they don't like limits. And if you do, I'd be inclined, if rather than choosing 15 to, I think, oh, the biggest ice cream name's 50 characters, so I'll make that 1,000 or something like that. If I have to have a limit. I prefer not to have a limit at all. You've got to be very wary of that because I don't know how many security exploits I've seen where the person doing the system said, right, people are going to enter passwords between 16 and 30 characters, so we'll set aside 2,000 characters for the hold it, and that'll be foolproof. And then some attacker comes along and supplies a 10 billion character password, which you can do, and breaks into the system that way. So be very, very wary of limits. All right, so ChatGPT, has given me this code. Is it good or not? It's almost good. It looks pretty good. It's close. I think DCC is going to give me an error. What's it called? I think it's called sp.c. It's my first error. Oh, I can see 2 errors. All right. First one's a stupid typo. DCC's telling me that's not allowed. Token types. What type is name? She's saying string. They're saying array of char. Who's right? Well, I prefer array of char because it's a bit more precise and low level, but string is perfectly good as well because that's how we store. Well, people interchange them in just talking about C programs. Yeah, but array of char is a better way of thinking about it because that's what it is, I guess. Well, it's not just an array of char, is it? You've got a point in that it has to be null terminated. Actually, no, it doesn't say it's null terminated, I guess, but yeah, anyway. All right. I'm assigning to an array. Can you do that in C? Can the left-hand side of an assignment statement be an array in C? Sadly, no. There's not a great reason for that. You could change the language and allow that. But when they did C, they said, no, assigning an array is an expensive operation. It shouldn't appear just as a single thing. Other languages will let you do that, not C. What do we do when we need to assign an array in general? For loop or while loop. Loop. Copy array element 1. Copy array element 2. Well, actually, we better start with array element 0. Copy array element 1. Copy array element 2. When do we stop? End of the array, I guess. When do we stop here? My friend here has pointed out it's a string there, so we actually would stop with the 0. Seems pretty tedious to have to write a loop to do this. So you remember my rule to make your coding life happier in many contexts. If you have a task, think, is the task that many people would have met before? Would there perhaps be a library function I can reach for that will do this efficiently, correctly, quickly? strcpy. You can't tell me what to do. One thing to note with strcpy is the parameter order is the same as an assignment. All right. Oh, you want me to include string? Oh, look, it's there already. Come on. And I'm typing my editor commands to the shell. Sorry, I've called that the wrong thing. This time for sure.
In the printf statement, you said ice cream is my ice cream.
I have two. Interesting.
Yeah, my ice cream is your ice cream.
I'd say all of this comes down to poor choice of names in the original example, by the way. All right. We're not doing anything with pointers yet. We're still trying to get there. All right.
Can you use the pointer
Yeah, I can do many things, trust me, but not yet, not yet. I can do so many things. But at the moment, I just want to get this to work. All right. Now, I've got this weird fear with strcpy. Why does strcpy make me uneasy? Why is strcpy might be something that have me wake at 4 a.m. worrying about my code? What can go wrong with strcpy?
if your array is the same size as and
If my array, it's not the same size I'm worried about, it's, yeah, I know what you know too. What happens if my array is too small? What will happen, the classic name for this is a buffer overflow and a security exploit. Okay, it's actually not a risk here because I can see this string here and I can count 5 characters, 15. But what happens if someone changes the ice cream name or changes the code? There is a much safer function. What's the much safer function?
memcpy?
No. You were so close. It's strcpy. So strcpy has a version that lets you pass. Well, I can use it. I think I can use it. Do I remember the parameter order? I think I remember the parameter order. Where you pass the size of the array, which I think is that parameter order. We'll find out. No, it isn't. All right. Let me. What? Oh. It's hilarious, really. All right, so there's a point there about manual entries. You'll have people like me saying use manual entries, but really manual entries are written for people like me. So it is something you'll have to slowly start learning to do. But they do have scary, weird sort of stuff in them that you don't need to know, like what the hell is restrict. sometimes it's better to have reference sheets. Do they get reference sheets in the exam?
That's a great question.
Maybe, yeah. They probably should.
Yes, they do. They do indeed.
Okay. Yeah, we don't want you failing the course because you don't remember which order, like me, don't remember which order the parameters go to string copy. All right. Yes, there's someone yawning. I know, sorry. No, I want to go a bit, you get a break soon. And, all right, so that's putting something in a struct directly. I can do so via pointers. And this is not going to look exciting, but it's opening us up to what will be a huge step in what we can do. So this is walking. So let me declare a pointer. See, I'm going to break this into 2 lines even. So I've declared a pointer variable. And what can that pointer point at? It can point at a struct ice cream. That's the only thing it can point at. You can't make it point at an int variable. You can't make it point at a double variable. You can't make it point at an array. All that's in the life of this pointer variable is pointing at struct ice creams. And I've said, make it point to this struct I've created. Now, if I compile my program, DCC will say, what? Oh, I haven't used the pointer yet. Let's use it then. Actually, let's change the name. We'll make it my pointer. Actually, my ice pointer. There we go. So you'd think you'd do something like this. Say indirect the pointer and then go dot name, and that's going to break. What's breaking here? Actually something that goes back to, I think it's year 4 or something like that. So you remember when you get taught that 3 times 4 plus 5, or actually 3 plus 4 times 5, what happens? You've got a plus and a times fighting over the 4 in 3 plus 4 times 5. Who wins? BODMAS? Did you get taught BODMAS? Yes, yes, you did. And your maths teacher's going, he didn't pay attention though. He didn't pay attention, Andrew. BODMAS. Precedence. So that arithmetic, the sort of arithmetic you teach in high school has 4 levels, 3 levels of precedence. C has 27 levels of precedence, I think it is the full horror. That's the bad news. The good news is you just avoid knowing about them by using brackets generally. So I can use brackets here to get around my problem. Which is, I could put brackets there, which is really ugly, but that will solve my problem, I believe, if I spell properly. All right, that's really ugly. It's hard to read that. Works fine. That says to reference the pointer, then do the dot. So that's using brackets to force the order. It's just like putting brackets around a plus to force the plus to happen before the multiply. So brackets 3 plus 4, brackets times 5 is different to 3 times 4, sorry, 3 plus 4 times 5. Forcing the asterisk to win and get the variable, and then the dot to happen. You're saying why doesn't dot set up to be the, yeah, it's a good question, but because in real code, not I'm learning to write code, not code that I can do in a 2-hour lab session code, but in code, 100,000 lines of code, the sort of code that may be in your future, because following a pointer to the field of a struct is a really, really common operation, the C designers said, no, look, we need a shorthand for it. If you're like me and have worked with compilers, you call it syntactic sugar. You think it's meaningless, but it's actually, it's meaningless if you're a compiler person working on the other side of it. If you're a human writing the code, it's wonderful. It makes things much easier to read and write. The syntactic sugar I'm talking about is this new operator, arrow, sometimes called dagger. You don't need it ever. You could always just use asterisks and dot and brackets. But arrow is just so pretty, so easy. Left-hand side of an arrow must be a pointer to some sort of struct. Right-hand side must be a field name for the struct. So it's a nice...
So could you flip it around and have name and then opposite side?
No, you cannot reverse it. It does not reverse. It's, yes, only one way. Only written that way. Now you've got me worried. I think that's true. All right, I can do the same. I can do this, rather than me do the same transformation. Actually, no, I will. I'll finish off. I'll take 30 seconds, a minute more, and then we'll have a break. If I've got that transformation right, all right, so there's using a pointer in miniature to access a struct. You look at that and you think that's stupid. You had a simpler program, Andrew, and you've made it more complicated and it does the same thing. True, definitely true, but it's demonstrating something that we're going to use to do much more powerful things. So this is a step on our way. All right, I think I need a 5-minute break. I think you probably need a 5-minute break. So quick dash to the bathroom, some yoga, whatever you want to do, 5 minutes sleep, and we'll resume again in 5 minutes. Our 5 minutes is up and we need to start again. I don't actually know the break time puzzle. I don't know the answer. Am I meant to know the answer? Sasha didn't give me an answer. All right. We're running a time. Ahem. If we could take our seats. All right. So Sasha has in her lovely lecture slides a similar example to the one we've just worked through. Sasha's a dog person, so that's just recapping what we saw. Copying a name to the dog, an age to the dog. You've got to understand every bit of that code. This is stuff you need to know to survive the upcoming weeks. That's the same code. We just did this transformation, converted to use a pointer. As I said, this seems stupid, but it's opening doors for us when we get to in other directions. This is doing things the weird way, well, not the weird way, using asterisk and dot from first principles, but we need brackets, and it's ugly. So there's a nice way to write it instead. Which is the arrow which we just saw. And you remember I call that syntactic sugar. It doesn't let us do anything different. It just makes us write things that are more readable, which is of great value in one sense and nothing in another sense. Oh. This is getting into COMP1521 territory. This is your taste of what comes in COMP1521, which has to be taken by all comp majors. If you're a mechanic, there shouldn't actually be any mechatronics people this term, I think. Anyone in mechatronics? They're the only people here who won't be doing COMP1521. So this is areas we're going to cover much more in your next course. Well, COMP1521 doesn't have to be your next computing course. Despite the numbering sequence, it's fine to take COMP2521 as your next course, by the way. You can do all. I would not recommend necessarily taking too many comp courses a term, but COMP2521 is the most crucial of comp courses because it's a prerequisite for many things. So it may be more sensible, depending on how you're planning out your program, to take COMP2521 next, not COMP1521. But you do have to take 1521 sooner or later. It covers where things are in memory in concrete detail, but we're going to give you a first taste of it here. We're going to talk about parts of memory, names you're going to see, stack, heap, and there's other parts of memory which you could use for global variables and code. Don't freak out much about these things. As I said, you won't get a full, exact, satisfying understanding of those until COMP1521. But we can start, because these things have implications for how we code, we've got to start talking about them. The stack. The stack is where functions put their variables. To this point, you've only seen variables that go on the stack, I believe. You've only seen variables inside functions. All the variables inside a function go on the stack. When a function is called, space is allocated on the stack for its variables. When a function returns, that space is removed. Why a stack? Imagine a stack of plates in a restaurant where they're grabbing plates to put food on it, and the dishwasher, there's a COMP1511 student who didn't listen to their lecturer, didn't get a good job, didn't listen to their lecturer. The dishwasher is putting plates on top of the stack. The stack is what we call a first in, first out structure. The next plate to be taken will be the top of the stack. Functions behave in the same way, where calling is like the person putting food on it and returns like the dishwasher, I guess. It's a good metaphor. I'm not sure it's a great metaphor, is it? Maybe. All right, forget my metaphor. Yeah, that's a good... Sasha's got a good point here, though. You as a coder can't do anything with the stack. All you can do is call functions or inside functions return. That's all you can do. Underneath it, the compiler looks after the stack for you. We want to be able to do more. I'll give you a taste of that. Yeah, this is pretty good. Nice diagram. How does a C program start? Call to main. So this program starts, main is called. How many variables in main? I count 5. So space for 5 variables will be allocated on the stack by the code for main. Saying, I didn't write that. Yeah, the compiler does it for you. You write a function, the compiler translates it into code that allocates space on the stack for those variables. So it might need, say, 32, 42, no, it won't be 42, 40 bytes for those. So 40 bytes will be allocated here to hold the variables from main. Now main, did you put all your code for assignment 1 in main? Hopefully not. That would be bad coding practice. You're probably, were they given code already with functions for assignment 1? Or?
No, there were a couple.
So we generally like to break our code up into functions of 10 or 20 lines. In this case, there's a second here function called sum. Ooh. So, look at this. This is a sequence. This is way beyond what I do in my lecturing. Sash is showing what it might look like. The space for main has 3 int variables, and number pointer, the 4th variable, is pointing back there. When we call sum, it's going to need space as well. And hopefully Sasha's got a diagram now showing space for sum. There we go. So if we were to peek in the memory of an executing program, and function main had called function A, had called function B, if we were to sort of forensically do our detective work and look in the bytes of the stack, we might see the variables for main, then the variables for A, then the variables for B. And you can do that sort of forensic analysis. So living in memory would be these variables, then that variable, and if some were to call another function, those variables. And there are things I'm not telling you here. So the students in COMP1521, which I'm lecturing, well, I have been lecturing, we went through 3.5 weeks, I think, of lectures to explain how to get to explain a full explanation of how the stack worked. So, and the first assignment in COMP1521 is the stack in detail. So this is just a taste of what's happening. It's important to understand what happens when sum returns, which is hopefully Sasha's next slide. When a function returns, all its local variables are gone. Why would that be bad? If you returned a pointer to one of those local variables, you'd have a pointer to something that was gone. And that leads to endless problems. You've got to be careful about that. So when sum returns, the stack goes back to just having the variables for main. When main returns, the stack will go back to having nothing. Yep?
When we refer to this stack, does it operate in a similar way to the arbitrary data structure of a stack?
Yes.
As in, like, you know, you pop one thing and then, like, the functions are popped out when they finish?
More or less. The truth, yes, in principle, yes. There can be more complexity out there. There's always more complexity out there in the world, unfortunately. And that's what I'm talking about. The finish, main returns, and there's nothing left on the stack. So I have another program here. I'm just trying to remember what my next program is and what I should talk about before we start on it. Oh, no, sizes of things. Okay, now that fits. Oh. So this is a classic student program. It's a good thing. You know, you get from good students who've been thinking, they've understood, pointers, there are references to things. That will let me do good things. Unfortunately, this good thing doesn't quite work. I'll show you how to make it work shortly, but this doesn't work. This is what I was talking about. This says, oh look, I'll return a pointer. And you can do that, sort of. The problem is, the array there is a local variable to create array. When create array returns, it's removed. It doesn't exist anymore. The space on the stack has been removed. It's been deallocated, is perhaps a better way to say it. So we're returning a pointer to nothing. If you want the scary truth about what can happen, you're returning a pointer to some bytes on the stack. If another function gets called, it might use those bytes on the stack. So you're returning a pointer to some other variable in some other function. If you assign to the pointer you've got, you might randomly change another variable in another function. Or if you use the value, you'll be randomly getting values from other functions. So you can get bizarre behavior, incomprehensible behavior, bugs which appear only when a program's been executing for 15 minutes and this happens. But there's worse, so much worse. Security. This is called use after free generically. Malicious people can exploit this sort of coding mistake to do things that you don't want to have happen. There is another area of memory which gets called the heap. I don't know, actually, I'm not even 100% sure why it's called a heap. There is a data structure called a heap, which is unrelated, really. It's just another part of memory that gets used in a different way. Yep?
So the stack is allocated, the memory for stack is allocated at compilation, right, or compilation. So the heap, is it?
The compiler just looks after the stack for you. You're behind the scenes. When your program starts running, the compiler's added code to create the stack. For each function you've got, the compiler's put code in that makes space for the variables of that function. For the heap, the compiler sort of takes care of it. It sets up a region initially, but we'll come to the but bit. After that, it's you. There's lots of good news here. So this area of memory, there's a region of memory where you can do what you like. All right. Now, think back to preschool or whatever. Is saying to people, is saying to a group of preschoolers, you can do what you like, necessarily a good idea? No, because they haven't learnt responsibility. They may do things that injure themselves or others. The same here applies with a heap. It should be used with caution and discipline, or you'll injure yourself or others. You're saying it's only code. So do you know when you fly, most of the aircraft you're likely to fly in domestically in Australia, the bigger ones, intercity, Sydney, Melbourne, you know they're fly-by-wire. Do you know what that means? So there's no physical connection between the pilot and the control surface of the airline. There's just code, C code. Actually, I'm not sure it's C code. Not sure what language the code's in, but there's code. If there's bugs in the code, what happens to the aircraft? The pilot can't control it anymore. Every time all of you, I think, probably all of you have flown in these planes, there's code there that's keeping you in the air. Anyway, all right, just something to think about. It used to be, there were people like me, when we used to get on aircraft, we'd look out the window or look at the sheets, say, is this fly-by-wire? But these days, everything's fly-by-wire. You can't avoid it. The heap. The function we want here has the catchy name of malloc, which is a contraction of memory allocate. I can say to malloc, I want some bytes of memory, and malloc will give it to me. I can say to malloc, I want 5 bytes of memory, 50 bytes of memory, 5 million bytes of memory, 5 gigabytes of memory. If I ask for 5 gigabytes of memory, it might struggle. Actually, that laptop there's got plenty of memory, but it will give me whatever memory I want to use how I like. malloc has a friend, a very important friend, which is called free. So it lets you say, oh, I'm done with this 50 bytes of memory I asked for a while ago. For every malloc, there should be a corresponding free to say your code's done with the memory. So a program should at one point allocate 5 megabytes of memory, and another point say, I'm done with that 5 megabytes of memory. But when is completely up to you, under programmer control. There's some good news and some bad news here. The good news is, in the sort of code you write, you generally write programs that exist for an instant. Even if you forget to free the memory, the operating system just cleans up everything when you're done. So for a COMP1511 student, your program exits in half a second. The operating system says, yeah, right, clean it up. The operating system doesn't even notice you didn't free things. That's the good news. The bad news is if you say you get an internship, you may well be writing code for a long-running program that's running for days, weeks, years. And it really, really then matters if you free the memory when you're finished using it. There's a lovely term for code that has an error in it and doesn't free memory when it's finished, called a memory leak, which means the memory use of the program will grow steadily. Famously, there was a ancient version of Windows, about the time you were born version of Windows, that had a bug in it where it had an operating system bug where the operating system would crash at 48.6 days, I think it was, or something like this. Just hard crash. The operating system would always crash then, but it took them 2.5 years or something to find the bug because so many of the programs they had on Windows had memory leaks that people always had to reboot their systems. So it was a long time before people had systems that stayed up for 48.5 days. So memory leaks, yeah, they're a problem for long-running programs in particular. But when we're teaching people to code, we insist on you freeing the memory you allocate. And we'll walk you through lab exercises of allocating memory, freeing memory, allocating memory, freeing memory. And it's good programming practice to do this. Oh, all right, we can go to... On screen. Not that code. That code. Yay. So I've given you Arrow, a new operator today. I have another treat for you. It looks like a function, but this is really an operator as well. Size of. Don't worry, size of's your friend. Well, size of's not too complicated. Let me finish my thought. Sorry, I don't multitask well. Size of, you can give it any C object, and it will tell you how many bytes it takes up. It can either be a variable or a type. If it's a type, you want to wrap it in brackets.
Yeah. Why do we use the unsigned integer percentage value instead of like percentage d?
That's sort of a because thing. That's the type. That's to match the type that size of returns. So size of returns a type that we don't use in this course, which is long unsigned. Come along to COMP1521 and we'll go through all the bits and bytes. But yeah, it's a perfectly good question, but I can't give you a... wait for COMP1521, I think is my real answer. So yeah, the type from size of is one we don't bother with this, and we don't get to in this course. We don't get to in this course. Still to come, in your future. All right, so I can run this program and find out the size of these types, how much these types take, if I can get it right. That might sort of make some sense. An int stored in 4 bytes, an array of 10 ints is stored in 40 bytes. Sort of logical, isn't it? Double stored in 8 bytes, chars stored in 1 byte. Again, this... Wait, well, you don't have to wait. You can research it yourself, but wait until after the exams and after you've passed maths, and you can research all of this stuff yourself. But come to COMP1521 with me or somewhere else, and we'll go in great detail into these things. COMP1521 will go and explain how doubles work. That's fascinating. Or scary, depending on. All right. So that's size of. Why have I brought up size of? How does that fit? Oh, wait. malloc. Malloc says, give me n bytes. But how many bytes do I need? If I want to store a 10-element array of ints, how many bytes do I need? Size of. Almost always when you're using malloc, there should be a size of. If you have got a malloc and you don't have a size of, you're doing something wrong. Wow. If you're in this course and you're doing malloc and not using size of, you're pretty much definitely doing something wrong, I think. What's my next? Oh, this looks scary and complicated. All right. On screen, consider the code. Oh, it's even better. This is great. Look at this. This is showing you something we couldn't do before. We want to read in n integers. Up until now, we've said n is fixed or less than a value. So the classic introductory programming exercises, read at most 10 integers, or you can assume at most 10 integers, or read 5 integers, because we declare fixed size arrays. This is using malloc to have an array that's exactly as large as we need. It could be for 3 integers, it could be for 3 million integers. Both will work fine. This is something new, powerful, and scary. So I read in the size, or more precisely, Sasha wrote this code, but oh. Malloc gives me back a pointer. If malloc couldn't allocate the space, it gives me a null value. You should always check that. It's surprisingly uncommon for it to actually get a null value. It's not something that happens very often, but
Would that happen if you ask for too much memory?
yes, so if I ask for a trillion bytes of memory, it will probably fail. Yes, it will. But you have to do operating systems in third year to get into some of the issues there. But look at this. So Sasha's given me code that I can put in a number in. It can be any number. It'll allocate space, read that number of integers into the space, and then print them out. I can say 1 integer, I can say 1 million integers. And I'm reading Sasha's code and I'm smiling. I'm thinking, there's the malloc, there's the free. What happens though, what the problem usually is complicated paths through the code. So this is relatively simple code. It's ensuring frees happen with all paths through the code. Let's try running this code first and see if it works. Oh. All right. I think it's called M.C. Oh, apparently it is. Does it work? How many numbers would I like to scan? Let's start again. Oh, DCSC is not happy with that. So I can put in 10 million. Now that would be a bit boring, me typing 10 million. So I'm going to go with 3. 3, 4, 7. Let's try it again. All right, we'll try it out. We'll ask for 100 million numbers. 1, 2, 3, 1, 2, 3. So that code has just created an array that can hold 100 million integers. It would be a bit tedious putting them all in, so we're not going to do that. Actually, we'll try a bit bigger then. No, we won't actually, because it might crash my laptop, and that would be bad. We won't do that. Actually, no, it shouldn't crash my laptop. Let's take the risk. All right, that's 10 billion integers in the array. That should be 40 gigabytes. There you go. All right, by the way, that working is absolutely amazing. It really relies on stuff that developed 60s, early 70s. The way that works with virtual memory is just stunning. So,
How big is your hard drive?
big enough to accommodate that. But the underlying work and operating system for that is amazing. But it's not part of 1511. All right. Yeah, I wanted to say a couple of things about these. Yeah, this does make my stomach hurt a little. All right, looking there at the print array function. What do we have? Pointers in an array in C, they're a subtle and difficult sort of area. Don't worry, in this course, we don't make you do anything that's particularly difficult. Lots of C programmers don't really understand the full formal relationship. This function, it's unlike anything we've seen before. It really is. We've got a pointer, but a pointer to what?
The start address of the array.
Is it to the array or is it to the first element of the array? It turns out they're the same. C guarantees they're the same. A pointer to the array and a pointer to the first element of the array are the same. How do I get to the other elements of the array?
You add a particular...
That was a rhetorical question. I really shouldn't ask rhetorical questions, should I? It's a lazy lecturing device. It turns out, and there's no reason you'd know this, it turns out you can use square brackets with the pointer to the first element of the array. So array, pointer to a first element array, very similar things. Not the same. Don't worry too much about the differences yet. But the big thing is I can use square brackets and print out the array like that. The other thing you'll see all the time then, when we're writing this great code that can have arrays of any size, is we have to pass around a separate parameter with the size. Any thoughts about how I'd get away from doing that? If I really just wanted to pass in one parameter? Yep.
You could do size of pointer times int. Size of
You'd think that. You really would think that. Size of won't help me out here. So there's just no way in this function for it to know how big the array it's been passed. It's got to be given it explicitly.
When you pass it in, you could do array of size of array times int.
So there are a few. See, this is a familiar path. You're thinking, I could do this, I could do that. Turns out C arrays are not as good as you think. Any way I could pass something in other than two parameters? Yep. Did you say struct? Sorry, my hearing is very bad. He said struct? That was the magic word, was struct. Oh, wait, have you got a Mars bar already? Oh. No. One Mars bar is my limit, but you deserve two. So struct was the Mars bar not winning comment. We could put the two things in a struct together and pass. Can you pass a struct as a parameter? Yes. Yes, you can. Whether you should or not is another question, or you could pass a pointer to the struct. All right, no Mars bar, but well done. Yeah, so that's the read array, print array. All right, this stuff isn't easy, this isn't obvious. Yep?
If you have a struct and one of the things in the struct is an array, and then you pass that struct into a function.
It's people like you that cause unrest. Yes, you can do that. Yes, you can do that. That's a classic C programmer's trick, saying, wait, I can pass the struct, but I can't pass an array. What if I put the array in the struct? And yes, that works, but compiler people hate you.
Wait, so
But it's not something we'd probably do in this course, but it is a programmer's trick, yes. All right. I think that's good. Let me go to the slides. Sasha probably had some logical progression she wanted me to go through to explain these things in a nice way. Oh, yeah. Yes, good, Sasha. I didn't probably explain this well enough. So that's making it crystal clear of what's happening there. I want to allocate space for X things, but how big is a thing? There's where size of comes in. Remember I said, you're using malloc, you're not using size of, you're doing it wrong. So I want space to hold X ints. I've got to use size of to find out how many ints. You do sometimes get students doing sort of big brain things. They think, I know size of ints are 4. Don't do that. Use size of. So trust me, there's a couple of reasons for that. One is it's just readable. That just reads and makes sense. Two, you may know less than you think. 3, the compiler just sees that and translates it, and it doesn't, you get the same result. I guess that's a nice graphical thing of what's happened. You saw me run that program and type in 3, then 12 bytes would have been allocated in the heap. I typed in 100 billion, I typed in 10 billion, and 40 megabytes would have been allocated on the heap. Oh. All right. All right, so get what we've seen so far in this program, work through it. I'm hoping everyone can understand the struct example, struct pointers example. This one's a bit harder, but work on it. But now I want to cover something that's, this is not something you need to know to survive this course or even to get a decent mark in this course. But this is my favorite function. There's a function called realloc. Which can be used to change the size of a piece of memory. And now I've got to remember, wait, I'm going to look it up. Can't remember the realloc order. Pointer first. All right, if your ambitions is to be a really good C coder, you have to understand realloc, but not today, tomorrow, or the next month. It's not something you need to understand necessarily to get through this course. If you do, that's great. But you should put another thing to put in a post-it note on the wall in the bedroom saying, after the exams, after I've got through maths 1121, learn about realloc. Realloc is when I've got a bit of memory and generally it's not big enough. I've allocated 10 megabytes and I've discovered I need 15 megabytes. I can say, it's a library function that says this bit of memory is not big enough, give me a bigger piece, but put the same contents at the start of the new piece. And its implementation is clever. It will try to allocate the same, leave you with the same memory, just extend it. If it can't, it'll move it. But if this works, that would leave pointer pointing to double the amount of memory.
Does that free up the memory? Or do you free?
So the question from my right was, can I realloc and make some? Are we okay up there? All right. The question from my right was, can we realloc and go smaller? Yes, we can. Not something the programmers do so much, but you certainly can. All right, so there are two functions there which I'm not going to finish. I'm going to leave as exercises for those who are finding this stuff comfortable and learning it. But let me repeat, realloc is not something we need to survive. I've said it's my favorite function. So why do I love realloc? Very often coding, we find ourselves in a situation where we've got incoming data. Might be numbers, might be bytes over a network. And we don't know how much there is of it. We can make assumptions, but I hate doing that. It just makes your code brittle, leads to things breaking, leads to people complaining your code doesn't work. Coders don't like limits in their code. I can use realloc, so I could set it, if I've got incoming numbers, I could say, all right, I'll start off assuming there's going to be at most 1,000. But if I get to 1,001, I can use realloc to grow the space. And then I can keep reading numbers, and I get to the limit of how much I realloc. The common realloc strategy would be to multiply the space by 1.5 or 2. And then I can read, and if I hit that limit, I can realloc again. Lots of good programmers write C code that's got a loop of reallocs to grow the space they read in. Is that the sort of space we expect you to write, the sort of code we expect you to write now, 7 weeks after seeing C for the first time? Is it in your future? Probably, hopefully. All right, so there are 2 functions to fill in. Yeah, I'm going to leave those for exercises because we're at 5 to the hour. Is there any, Sophie, Tom, Ben, nothing else I should be saying? No more questions? All right.
Scroll up a little bit. I want to see how you're standing there.
It is on the class website. Should be on the class website. Okay, will be on the class website. There's how I'm scanning it. All right, Thursday, more with malloc, but we're going to mix malloc, pointers, and structs to enter a new world. See you Thursday. Thank you for turning up in the rain. Thank you for your attention.